Chapter 2, Section 3, Multi-Step Equations. Section 1, we learned about one-step equations. Section 2, we learned about two-step equations. Section 3, we're going to learn about multi-step equations. We're going to have the additive inverse in it. We're going to have the multiplicative inverse in it. Now we're going to start learning about things like combining terms. Let me show you what I mean. Let's say we had an equation here, 3x plus 7 plus 6x equals 34. If you notice right away, we see that there are two terms that are alike in here, 3x and 6x. In other words, their x's are the same. It's not an x squared or anything like that. It's an x to the first power, which means that we can combine these two. We can combine them together because their x's are the same. These are like terms. So we would add the coefficients out front, 3 plus 6, which is 9, and we'd put the like term behind it. All right? We can bring our plus 7 in and say equals 34. All we've done from this step to this step is combined our like terms. Now this looks like something that you can work with. You've worked with before. Well, let's continue on. We know we can do the additive inverse here. So we have a plus 7. Let's make it a minus 7. We do it on one side of the equal sign. We have to do it on the other. Carry our 9x down. Equals, this goes to 0, equals 27. We have a 9 here. So if we multiply by its multiplicative inverse, 1/9, and do the same thing on the other side, then the 9 and a 1/9 cross each other out, and we're left with an x, and we're left with 27 over 9. Well, x equals 27 over 9, or 27 divided by 9, is 3, and there would be our answer. Let's go back to that same equation now. 3x plus 7 plus 6x equals 34. We learned that x, through doing our math, equals 3. How can we find out that this is really, how can we confirm that this is really the right answer? Well, we can take this 3 and we can replace it for each of the x's that are in here, right? X equals 3, so replace it. Let's try that once. 3 times 3, replaced it, plus 7, plus 6 times 3 equals 34. Well, 3 times 3 is 9, plus 7, plus 6 times 3 is 18, equals 34. 9 plus 7 is 16. I always like doing it this way. I break it down in pieces. 16 plus 18 equals 34. Well, 16 plus 18 is 34, equals 34. We just confirmed that this answer, x equals 3, is the correct answer for this equation. Let's take a look at a couple other examples, and I want to do one here that may be a little bit tougher to see because there's multi-steps that we have to do in this equation. And this one would be 4 times, in parentheses, a minus 2x minus 3 equals 12. What would be the multi-step on this one? Well, the multi-step would be first carrying this 4 through the parentheses to make sure that we can break this down easier. So let's carry our 4 through. 4 times a negative 2 is a negative 8. We keep our x. 4 times a negative 3 is a negative 12. We've now carried our 4 through, so let's just carry this 12 over. Now we can take a look at it and we say, okay, we have a negative 8x. This is a multiplicative inverse. Negative 12 is the additive inverse. Let's get rid of our additive inverse first. That's what we want to do first. So we have a minus 12. Let's do the additive inverse of 12 plus 12 on both sides. Bring our negative 8x down here. These cross out and go to 0. We've got our equal sign here. 12 plus 12 is 24. Now we can do our multiplicative inverse. We have a negative 8 the multiplicative inverse to this is a minus 1/8. All right, if we have a -8, the multiplicative inverse is a minus 1/8. What we do on one side, we have to do on the other side. Well, now we know that -8 and minus 1/8, they cancel each other out, and it just leaves with an x. And over here would be minus 24 over 8. Or, if we were to write this out, we have minus 24 divided by 8 would be a minus 3. And there would be our answer to this equation. Let's take a look at one other, and that's dealing with fractions. And the one I want to put up there for fractions is going to be 6x minus 5/8 equals 7/8. Yes, I'm taking these out of the book, and I'm not coming up with them in my head. Okay, first thing we look at this is saying, well, it's pretty straightforward. We have a multiplicative inverse and we have an additive inverse. So what is the additive inverse to 5/8? Remember, we do the additive first. It's a plus 5/8. And if we do a plus 5/8 there, we have to do a plus 5/8 over here. Bring our fractions down. 6x, this goes to 0, which we don't have to put in there. 7/8 plus 5/8 is 13/8, or 12/8, I'm sorry, 12/8. All right, what do we do next? Well, we have to do we can reduce this if we wanted to, right? We know that 12/8 can be reduced to what? Well, in each one of these, a 4 goes into each one of these, right? So we can reduce this if we want. 6x equals, divide the top by 4 and divide the bottom by 4, and we come up with 3 halves. It may help. It's going to help us down the road, I think, here. Okay, now we have our 6x equals 3 halves. What would be the multiplicative inverse of this? Well, we'd multiply this by 1/6, right? And we'd have to multiply this by 1/6. Now you're starting to use a little more of your math that you learned in your lower grades here, all right? And I'll show you why. Well, this cancels out, so we're just left with an x here. But what do we have on the other side? We have 3 times 1, which is 3, divided by 2 times 6, which is 12. Is that our final answer? No, it's not, because our 3, we can reduce this fraction, right? We know that 3 goes into both of these, so we can divide the top by 3 and divide the bottom by 3. And we're left with x equals, 3 divided by 3 is 1, over 12 divided by 3, which is 4. And we end up with 1/4 is our final answer.